Hi, I'm Fred. I'm the machine learning lead at Encord. In this episode, I'm going to be talking about a model that we developed on top of the dataset we released. It's very natural to sort of establish a baseline, at least, from the big multimodal dataset. And we did that in two phases, kind of aligned with how we released the dataset. We have a pre-training phase where we used only these automatically generated quintuples. And on top of that, we used a post-training phase where we used all the high-quality data as well. And so for the pre-training phase, we actually see that if we employ a very simple info cross-entropy loss, which is like very common in the field of these contrastive models, then we actually see performance that is beyond much of the related work. Then, of course, like on top of that, we took all this high-quality data. And when we do that, we can see a very big jump in performance on multiple of these retrieval tasks between different modalities. One of them is between images or videos and audio. You have this naturally co-occurring modalities. This is really mostly meant as a baseline for what you can do. There are many tricks that we have not employed. In the previous episode, I mentioned annotating whether a match is good or if it's partial or it's bad. And that information, for instance, could be fused into the loss function. Another thing we did not do is use the attention mechanisms of all these modern transformers. So we basically took the classification token of all these different embedding models and produced models on top of that. We're publishing the embedding from our index with every data point, so you can work on top of that embedding if you want. But you could also take the entire sequence of tokens from patch embeddings, for instance, or the tokens from your audio files, and that would naturally give more information to the system. You could unfreeze more parameters, all these kind of things. So there's much more performance I think you can gain if you really harness all the tricks out there. So yeah, I'm really eager to see all the cool improvements on that front. Another thing I wanted to mention here is that we are only at the very beginning of all the applications you can build on top of these types of retrieval models. Many of the generative models are built on top of retrieval models. So when you're generating an image with stable diffusion, you actually take an image retrieval model first, embed the caption or your description of the image, and that embedding is the information for the diffusion model. So in a similar vein, you could do this for all these different modalities. Another thing is, suppose you had a RAG system that could work across all these different modalities. Maybe you're a robotics company and you're trying to understand different features in the space. You could search for your 3D point clouds. That also feeds very well into LLM. So if you have an in-house LLM and you want to have your audio and your images, your videos, then this is another sort of avenue in which you could do that. So many applications and many sort of modes in which you can improve on the model. And we are really eager to see all the cool stuff that you all are going to be building.